Lesson number 43, sine, cosine, and tangent and inverse functions. Sine is written out this way, and because mathematicians love to shorten everything up, we shorten up sine to this. Makes it so much easier.
It makes
it's
it
not
on the
pronounced
calculator,
sin, although some of you may think it appears to be. Cosine is written as cosine, not cos. Do not call it sin. Do not call it cos.
Cosine.
What can we call it then?
Cosine.
Can we call it cosine?
Then we have tangent, which is quite the lengthy word, and they shortened it down to tan. I don't mind if you call that tan.
Why can't I say sin or cos?
Okay. There are three other trig functions that we probably won't get into this year. I don't know, maybe we will. Cosecant, secant, and cotangent.
Can't see.
No, thank you.
So,
Can't happen.
anyway,
Use the HYP better.
the what?
HYP.
No, we won't be using it.
What's that for?
I have no clue. I've never used it in my life.
What about DRB or
I don't know.
DRG?
Okay, anyway,
It
guys,
doesn't do a thing.
little bit of theory here, so I need you to pay attention. Sine, cosine, and tangent. Adam asked me earlier. So, what do those things represent? What are they? I mean, are they like a number, like pi is 3.1415 into infinity? What in the world is a sine, a cosine, and a tangent? Those are words representing ratios of certain sides of a triangle. So, for instance, if I have a triangle here, and this side is 3, this side is 4, and this side is 5. And I am interested in the ratio of two of those sides. I want to see what happens if I take the ratio. So let's say I take the side that's 3 and the side that's 4. That's a ratio, right? Okay. So 3 to 4. That is a sine, a cosine, or a tangent, depending on what we're doing. And I'll teach you how you determine that in a minute. But that's what those are. They're ratios showing the relationship between different sides of the triangle.
All those are?
Every
Sine,
single
cosine, and tangent, all
every
are.
single person who builds a house, does construction, uses trig, but they don't know it. Because they have figured out another way to do the trig without having to do the trig. And the minute I tell them, oh, you're using Pythagorean theorem and you're using sine, cosine, and they're like, no, I'm not. I don't even know what that stuff is. They figured out a way to do it without having to know the math, which is fine. It all works.
Can we do it that way?
No. All right. Sine, cosine, and tangent will only work when the triangle is a right triangle. Key word is only.
Right.
It will not work with any other triangles. If I draw a triangle like this, that isn't going to work. You cannot figure things out in that kind of a triangle. It has to be a right triangle.
All three, sine, cosine, and tangent, only work with right triangles?
Yes. And secant, cosecant, and cotangent later on.
Only
Works with the right triangle. Yes. And then all the inverses of those, yes. Which you will learn too.
Okay.
All right. When I ask you a question and I'm interested in a sine of something, I'm going to ask you the sine of an angle, the tangent of an angle, the cosine of an angle. So let's say, for instance, this is a 30-degree angle, and I ask you what the sine of 30 degrees equals. Okay? So when you're given a sine at this point in your math career, I will tell you what angle we're looking at so you can figure out the ratio. Because the sine of 30 degrees, the tan of 30 degrees, and the cosine of 30 degrees will all give you different answers. All right, so the sine of 30 degrees you said is 0.5. The tangent of 30 degrees is 0.5773. The cosine of 30 degrees is 0.8660. Because we got different numbers, that tells me one thing. It tells me the ratios are different for each one of these. Because if the ratios that I'm looking at are the same, we would get the same answer. Okay, so this is how the ratios work. I don't need these anymore. In fact, I'm not even going to use these anymore. Let's get rid of those. So, the sine of 30 degrees equals, here's the ratio, the side opposite the 30 degrees over the hypotenuse. So what is the side opposite the 30-degree angle? It's the 4, the side that's across from it. What is the hypotenuse? 5. There's my ratio, 4 over 5. My cosine of 30 degrees, and these numbers are not correct, this 3, 4, 5, I just threw them up there. But anyway, it works for what we're doing here. The cosine of 30 degrees is the side adjacent to that 30-degree angle over the hypotenuse. What is the side adjacent to my 30-degree angle? 3. How do you know it's 3 and not 5?
Because the 5 is my
The 5 is a hypotenuse. If the hypotenuse is there, it can't also be an adjacent. Although it is adjacent, it's a specific adjacent line called the hypotenuse. So it has to be the 3. So it's 3 over 5. So see how the ratios are different? That's why we get a different answer. The tangent of 30 degrees is opposite over hypotenuse, which is what? I'm sorry. Not hypotenuse. Adjacent. Okay, what's the opposite? 4. And the adjacent? Okay. This is the clue that I give you. I have not really seen this clue in many books. I see a bunch of stupid clues that are really, really hard to remember. But I'm going to give you a clue in order to help you remember. If I say, okay, Riley, cosine is what ratio? And he's like, A over H. And I say, how do you know that? And he's going, because I have my notes here and I've got it, or it's up on the board. So you need to come up with a way to remember these. And the way to remember them is an old Indian chief back in the Southwest who invented this acronym in order to remember sine, cosine, and tangent. His name was Toa. Doesn't that sound like a good Indian name? SOHCAHTOA. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. I learned that in 10th grade. I still remember it. Plus teaching this every year, I remember it, but I remember that. Cool. SOHCAHTOA. Be able to, when I just rattle off, okay, what's the tangent of that? You go, SOHCAHTOA, opposite over adjacent, and you remember what it is. Now, this bit of information goes in a lot more depth than what we are this year. Just ask Kara. She took college trig last year, a whole semester of just doing this.
Just that.
And she lived through it. Although she'll never be the same, she did take it.
But why?
She'll never be
It was just that. That's all it was.
All right, so let me put another angle up here.
SOHCAHTOA.
All right, can I use trig functions on that triangle?
Yes.
I heard a bunch of yeses.
Is it a right triangle? It looks very right.
Yeah.
We don't know.
Might not be
Yeah,
There's no way to determine because we don't know if it's a right triangle yet unless I tell you it's a
Now you
right
can.
triangle. Now
Oh.
you can. All right. Let's look at a couple things here. 60 and 120. And let's say that this is, again, 30 degrees. What is the bottom one?
Oh, I
Let's
know.
find the.
It's X.
It's not 60.
Aw, that's sad.
Okay. How would you find out what that bottom line is? What it represents?
A squared.
A squared plus B squared equals C squared.
Oh,
Yes.
we're in
You
trig.
go ahead and figure that out. Pythagorean works a lot with trig and with geometry. So, in fact, what they have for the clue in this book is Oscar had a hold on Arthur. So, Oscar had is the sign, a hold, which is your cosine, on Arthur, which is your tangent.
That's so much easier.
I know, it's stupid.
Oscar had a whole lot.
Yeah, I mean, remembering that. So,
Sokatoa. That's gonna be hard.
Were you on the heaven hallway?
No, I wasn't on that. I watched
so
you.
at this point, guys, and in advanced math classes, well, you guys tell me, do I prefer decimals or fractions?
Fractions.
Fractions are
And
think
I
decimals.
fractions. Why is that?
They're exact.
They're exact. Ah, that's what they say because you're evil and like to make life harder on you.
I
Well, that
hate
is true,
fractions.
but they are exact. Fractions are more exact than decimals are, especially when you're doing sine. You take the cosine of 30 degrees, you're going to get this, it goes into infinity. Whereas if you write it as a ratio or a fraction, you've got the exact number that you're looking for. Yes, Kendra?
I got that.
Did you use Pythagorean? And you got what?
103.923.
Yep, that's exactly right.
About 36 over 27.
Nope, you're wrong.
Oh, what if Madison's spending all this time to do it out with still the little tree thing?
Yeah.
Well then, yeah,
Yeah.
it takes you a long time, doesn't it?
But do you want it with that still?
With the little tree thing?
With this?
Factoring.
With the number on the outside?
Oh, radical.
Yeah.
Some of these you're gonna have radicals in, yeah.
But I mean, should we find the square root and have some random long decimal, or do you want it?
I'd rather let it left in the square root sign.
But then you have to
Okay.
simplify it, right?
Yeah. Anyway, we're going to just hit a bunch of stuff real lightly today when it comes to trig, and then as the next weeks go, we're gonna take each bit piece by piece and go into a little more depth.
Okay.
So just some real light stuff. All right, so back to my triangle. I gave you
High school boys, please be sure to clean out your locker room. There will be teams staying here this weekend, and that goes.
all right, taking the sine of 30 degrees, you found out using your calculator that that equals 0.5. Sometimes you're given the ratio and you're not given the angle. And sometimes you need to find out what that angle is. Okay? So, I'm going to show you how, Michael. Before you groan too hard, it's just an extra button on your calculator that you push.
Effort that
Okay, so guys, I need you to focus here.
a gram of energy.
If I give you this here, and I am interested in the angle, I will ask you what is called the arc sine, or the way you write that in shortened form is sine to the -1 power. That's what that means. If you have a button on there like that,
Yeah.
you put in 0.5, you push sine to the -1 power, and you should get 30. Oh, hot dog. Okay, not real hard. It's just the
I got an
inverse.
error.
It's going backwards. You probably your calculator probably wants you to do it backwards. Maybe it wants you to put
You
sine
do
as
sine
negative
first,
1,
that's how I
then
learned.
20.
Ah, I got it.
So,
Maybe mine's not. Good job, son.
let's try one of these.
Mr. Reiner,
Yes, sir?
Oh, whoa.
on my calculator, I get negative 0.98. There's a tiny triangle in there.
Look and see if this is in radians.
Like, on hers,
Oh, it's
too.
yours.
Yeah.
Okay, so what I've got up there is I've got a triangle with the lengths of all three sides there for you to see. And what I'm asking you to do is to find what angle C is and what angle A is based on that information. Okay? So, what I'm asking is, if I take the ratio of two of those numbers and hit my arc sine button, it's going to give me the degrees. Okay? So let's say, for instance, I'm looking for C. Okay? So C equals, do you want to find the sine, the cosine, or the tangent?
You want to find.
When you're given all three sides, it's up to you. It doesn't matter. When you're only given two of those sides, then it does matter. You've only got a couple different options available to you. You know, but in this one you can use any one you want. So Ben, which of the three you want to use?
Sine.
Sine? Okay. So, sine. What is the ratio of the sine of C? What is that ratio?
Hypotenuse.
Opposite over hypotenuse, which is
3.61.
over. Okay, so the sine of C is what? What is 3.61 divided by 7.52? 4 digits. 0.4800. Okay, what if I want to know the arc sine of 0.4800? $28 point what? 68.
I got
Degrees.
69 points.
So, angle C is 28.68. Now, let's say that I asked Seth what trig function he wanted to use, and he chose tangent.
Wait, so that 28.685 whatever is the C?
That is the angle C. Now,
Yeah, we just subtract those from.
yes.
Yeah.
So, 28.68 or 28.69, if that's the angle, right? It's not going to change depending on my ratios.
Correct.
So if I use sine, cosine, or tangent, it's not going to make any difference at all. I better get 28.685.
So let's try.
So
For a
if you
degree.
wanted to check your answer, you could do it a different way.
So yeah, so let's try the tangent of C. What's the tangent of C? What's the ratio?
And it's to opposite over adjacent.
Okay, go ahead and take that. Okay, so now take the arctangent
33.545.
of 0.5469.
33.
I got 28.6742.
Okay, so you get the same angle.
It's about close.
Yeah, yeah, because we, instead of taking this forever and this forever, we rounded, so we're a little bit.
So what did you say?
Oh,
28.6742.
we did with cosine, we would use this adjacent over hypotenuse. And we would take the arc cosine, and we'd also get 28.67. something.
Well, your 9 should have rounded up, which would have made it
I
a
have a question.
7.
Yeah.
When you write out like the sin, cost, hand,
Yeah.
but do you write it in all caps or does it matter?
Good question. You never write your sine, cosine, and tan in capital, nothing in capital letters. Because when you get to advanced math and higher level trig, a capital C on cosine means something different than if you write lowercase cos.
So you do.
Everything lowercase. Because capital C lowercase os means something different than lowercase
So you're writing in
cos.
all caps.
That's because I always write in all caps.
It looks better on the board.
Yes.
Oh, so
You don't want to. I don't even remember my lowercase letters. So
Write it. Write in lowercase something. Do it now. The whole alphabet.
I don't know how, Riley.
Yes, you can.
Okay. So,
And
any questions?
It's so funny.
Oh,